All right, so tonight we're going to try to look a little bit at processing and graphing some data in Python. Sources of data are pretty much everywhere. And we're going to pick one that is local and easily accessible. Not sure what's happening here. Okay, let's enlarge it. All right, so this site called datagov.sg, is it visible? Okay, reasonably visible. Cool. Has all sorts of things. Data that the Singapore government makes public. Right, so this is the front page. You have stuff related to economy, education, right? It's pretty much all the data that the Singapore government wants to make public. Yeah, including at some point we can find controversial stuff like, how many executions there have been per year, every year, and so on, right? So stuff that is well known. The government makes available in a electronically readable format, right? So that it can be easily processed by software tools, right? We're going to pick something completely non-controversial. Number of days of sunshine, right? So one thing we can look for here is sunshine. Right, I know it so well because I looked for it last year, and you can open it, and they already will provide some visualizations, right? And you can go and study, and for each data set that is available, they will provide relevant visualization, statistics, interesting stuff. But if you want to do your own, you can go here and download, right? And what you download, I'm not going to click again because I have done it already. When you download, what you get is a zip file. Hopefully I think I don't have the zip file anymore. So what you get a zip file, and inside the zip file you'll see a bunch of files, one of which is going to be in this format called CSV. All right, so this is a text format. We can load it in a text editor, and I've done it already here, right? CSV stands for comma separated format, and it's a table, right? At the first line will tell us the name of the columns. So we have the month and the mean of sunshine hours for that month, right? So for instance, for the month of January 1982, we had 5.6 hours per day of sunshine. And so on, and it goes and goes and goes and goes and goes. It only has 400 lines, so it's very small, right, by today's standards. Big is trillions, hundreds of billions or trillions, right? Medium, millions is still small, tens of millions. So 1 billion is maybe average, is medium. All right, so the also interesting stuff, if you don't if you don't want to work with Python, you can put this in Excel, right? Excel might have some hiccups in importing and parsing it, right? But not here. Oh, there surely is a license. And you can see the table and the numbers, right? So it looks at every line, looks at the comma. The comma is the separator between columns, and it figured it out. And that's the table, right? It's a very simple table. Now, if we want to process this with in Python, all right, what we can do is, this is the assignment. So the assignment is going to be very similar to what we're doing now. is we want to be able to read this file straight from the disk. All right, so it's already on the disk. I downloaded the zip file, I unzipped, and I have the CSV file there. There's also a TXT file, which, to tell you the truth, I have no idea what it means. Oh, it's metadata. So I could open this in a text editor as well. And this will tell us some information about, some description about the data that is in the CSV file. Right, so this is always interesting to see. So let's look at the code. Right, so how do we open a file? We have two separate commands, right, in reading a file. Opening, right, and in opening the file, we create a descriptor of the layout of the file on the disk. This is largely historic. So nowadays, we don't quite need that. But in the past, access to disk was expensive computationally, right? So most of the time, you wouldn't want to read an entire file into memory. You wouldn't even have the memory to read on an entire file. Most files were larger than the amount of memory that a machine would have. So therefore, you would perform this initialization operation of opening a file. So what was brought into memory at that point was sort of a map of the file on the disk, so that the information could be retrieved from the right place relatively easily. And then, once we had this file handle, so what we get here is a file handle, we would be able to perform operations like reading, writing, appending, right, overwriting, searching, and so on, right? Nowadays, more modern APIs will just read a file in memory and will give it to you as a string. And what you do is you process the string as you would process any string. Most files actually occupy a very small piece of the memory. And then you just overwrite. You just write it, and you might write it in a separate file, or you might just overwrite the previous file, and that would count as an update. But nobody really bothers with, let me be optimal in updating, very specific chunks. This only happens when the files are very large. But when files are very large, we have resorted to different types of storage. So most typically, we try to store data in a database, not in a file, or we try to store data in a distributed file system, right? And for those, because it's a completely different kind of architecture, we have separate different ways of different protocols of accessing a file, right? But Python is a 1994, 24-year-old language, right? So it still has this legacy of processing a file the way it used to be. At least the standard library has it this way. Now, what we do is then we read a file, and luckily we have a package called CSV. Can you actually read this? Yeah. Just to be possible to enlarge it a bit, right? To parse a CSV file directly. So what we get here is essentially not an array, but an iterator to an array, right? So the iterator to an array allows us to read one row at a time by performing this operation next. But what happens is that iterators are just sequences, pretty much like lists. So we can use them in comprehensions and in the map, in the map function, right? So what we do is we just take this iterator and we treat it as a list, and we put it inside a map, and we want to process it. Okay, so what do we want to do first? We want to create a reasonable representation of the data. All right, so we read it. We have this iterator that essentially contains the sequence of rows, right? The row itself is a little array. So the table is like a matrix, where the row is a little array where A0 is the first column, the value in the first column, and A1 is the value in the second column, right? Now, if we look at how the data, if you're wondering why do I do this, next just skips a row, right? Is because I want to skip the first row, which has the names of the columns, which are not so interesting in terms of processing. So if I go here, right, if you look at the structure of a row, we have in the first column the year and the month separated by dash. So you could say that we actually have three columns. We have the year, the month, and the average number of hours per month of sunshine, right? Just that between the first and the second column, between the year and the month, we have a dash instead of a comma, right? It would have been very useful to have a comma. So because of that, we want to convert this into something that is more palatable to us. And we're going to try to split the contents of the first column, the value in the first column, into year and month. All right? So how do we do this, right? We map, right, on this IT, we map a lambda, right? So this lambda D is for data, and D0, right, is the value in the first column, right? So this D0 is the value in the first column. And what you see here is that we're splitting this into two separate values, right, on the left and right hand side of the dash. So this split command will identify whatever string I pass in as a parameter, and we'll consider that a separator, and we'll separate the string by that separator, right? If we had 3 dashes, for instance, we would have 4 separate values coming out of it. So this entire highlighted expression is in fact the subarray. It's an array, but we're already having already D0 is an array, right? So this becomes a subarray with 2 fields, right? One is the year and the other is the month. So what do we do with this? Well, we perform a separate map on it, right? So there's a first lambda and there's a second lambda. Right? So we're converting this. What does this become, right? So this has 2 values, right? So A is 2 values. A0 is the year, A1 is the month, right? So we're going to convert it into a tuple. If you look here, this is a tuple. So we're putting here the year, we're putting here the month, and then coming from this IT, because initially D0 was year plus month, and D1, from this D1 was number of hours, right? So this D1 goes in here. So we're converting the whole thing into year, right? Year, month, number of hours. And everything is inside a triple. So we have converted 2 columns into essentially 3 columns, right? And we're returning this into a list. So the result of this function is a list of triples where the first component of the triple is the year, the second component is the month, the third component is the number of values. So let's load this and see that we have what I promised we would have. And again, for simplicity, I'm just going to use idle. Yes?
What does the map function do again?
All right, let's remember the map function. So if I apply a map, of lambda x plus 3, let's say, to a list 2, 3, 4, 5, 6, 7, right? What I'm going to get is an iterator, right? So if we want to visualize the iterator, it's better just say list here. Right, so you see each element from here has a 3 added to it. Right, alternatively, instead of x equals x plus 3, remembering the discussion we had last time, I could say 3 dot add. Right, leads to the same result. So essentially, I have a list of objects. I want each of these objects to be subjected to a function, right? Map can help me apply that function to each of the objects in the list. Okay?
And you have to use the list at the front because it outputs an iterator.
So let's say otherwise it's an iterator, right? And which is fine, just that if you want to visualize, what you get is this object, right? Because an iterator is potentially infinite. So as soon as I start printing it, there's not necessarily something that would stop me unless I reach the end, right? So I can easily create an infinite one. For instance, I will say def inf, and do I need to say anything? I can say n equals 0 while true, n plus equals 1, right? So I want to create an infinite iterator. I will say it equals inf, right? So now it is an infinite iterator, but you don't see anything. You don't see an infinite loop because I haven't tried to evaluate it, right? So, for instance, if I say do I have a take? No, so I have to say import iter tools, I think, and then dear iter tools. And do we have a take while? Have a take while is slice zip longest, accumulate package, drop while. Right, so one thing I could do is, so from iter tools, import take while, right? And then I can say list of take while of lambda x less than 10 and it, right? True is not defined. My mistake. Go back here while capital true. Go back and create the IT. Right, so we see 9 objects, right? So we have consumed of the infinite iterator, we have consumed 10 numbers. Now, if I do list it directly, right, it's infinite loop, right? You don't see anything printed because it's infinite. All right, and luckily Control-C works. Okay, so now one thing I can do, for instance, is say it dot next like this, or it dot next. Sorry, next it. Yeah, we're getting stop iteration. Why is that? Because we pressed Control-C. So right, so for instance, while it's not a very interesting iterator because it prints all the numbers from 1 to n. So let's do another one. Let's yield n times 10.
What is yield?
Yield is like a return, but next time when I call, I'm going to resume from after it. Okay, so you see, so this is what an iterator really does. It equals inf, right? So now I say next it, and I get 0. Next it, I get 10. Next it, I get 20, right? So what happens is that I create a, so this one, as soon as, this is a function, right?
Yes.
But as soon as Python sees that there's an yield inside, it turns this thing into returning a lambda, right? So this itself is actually a lambda. When I create an it becomes a generator, which in turn is actually a lambda. When I do next it starts executing, right? It gets to yield, and this is the value that is returned first.
0 times 10.
Right, 0 times 10. Then when I say next it will resume from after the yield. It will go around the while loop, it will reach yield again, it will return 10, right? Because n has increased. And then it freezes, right? It's not, the computation is not done, but it's frozen, right? When I press next again, right? I'm going to do another one, right? But the interesting thing is that this is just a sequence, right? So I can use it in comprehensions. For instance, if I say, so remember, right, that we have consumed 0, 10, 20 already, right? So if I say I want to return I, all right, for I in it, if I less than 100, right? So this is a list comprehension, and it seems that I got an infinite loop again. Where did I get? Why is it? Okay, I can create it again. I for I in it. Why does it go into infinite loop? Anyway, the important thing is that we can just treat it as a sequence. Most of the time, we don't write infinite ones, right? So we could write very well-behaved ones. So let's write the well-behaved one. So while n less than 1,000, let's say, right? So now if I do this, seriously. Oh, because I haven't created a new one. We have to do it-inf, okay, and now this one should work, yes. Okay. So this is a finite well-behaved one, right? And the important thing is that the list, the distinction is that the list will use memory for all the numbers, right? So all the numbers sit in memory at the same time. And sometimes that's a good thing because I need them all at the same time. But an iterator will only give you one number at a time. It will replace the previous number by the current one. So if you're not careful to store the current number somewhere, then you lose it, right? And the advantage of the iterator is that it uses very little memory, right? It doesn't use infinite memory. And because of that, you can also use it to represent an infinite computation if you want that. All right? So we can use map and filter and whatnot on it. Whenever we use sequence processing functions, right, even though the input might be a list, what we get out is an iterator, right? Because the system doesn't want to force us to consume more memory than we need. So if we need the iterator turned into a list, we should do it ourselves, right? It's our responsibility because we're the ones who know what the memory constraints of the application is, right? The system by default will just try to you do that in a way that minimizes the memory footprint. All right, so I am going to open the file that we have just seen. Actually, we can simply pass in the two functions. That's easier. So I'm going to pass in both of these. Actually, I think I can pass in both. Let's just pass them one at a time. All right. So, the other thing that we need is the file name, the complete path to the file. So we're going to look at the properties. We have an easy way to access the path. All right, maybe not. So here we should be able to, oh, but not a txt, this one. So we're going to do get data, and let's put the result in something like r equals get data, and oh, where's the full path? I see the full path is here. And we have to double the slashes. You know why, right? Because backslash is an escape character. So backslash n, for instance, is new line, right? So a single backslash would be misconstrued as something, as an attempt to escape something, right? So backslash then means backslash. So now we have R, and you see that R is a very large list. It's actually not that large, but it's large for our computer screen, right? But what you see inside is triples, as we said, right? So we have a triple where the first component is the year, the second component is the month, and the third component is the number of average hours of sunshine for that. Okay?
They're all strings, though.
They're strings. That's true. But that conversion from string to number is not difficult in Python. Is quite straightforward, right? So we want to plot this, right? And we have a library that plots the entire thing. All right, this matplotlib. All right, with pylab. The question is whether they're available. So let me see whether they're available. So I'm going to do the second one bit by bit. So let me, actually I won't be able to do 2 lines at a time. So let's do them one by one. So what we need to do, can I do what was the package? The package importer Python. Python. Yeah, I just have I can't remember for the moment what's the name of the command. Python install package pip. So do I have a pip here? No. So if I don't have a pip here, then I will go and get a command prompt. Don't do that. And is it local? Come on. Oh, it wasn't there. Let me find it again. Oh, this is just okay, python.exe. Here we should find pip. No. Tools. Okay, let's look for pip.
Script.
Yeah, simsay. I never quite understood why in this search I cannot see the full, like whatever I do. Okay, scripts. All right, so now I should be able to say install matplotlib. So it will go and on the web and figure out where it is and install this package. Okay, not interesting to us. Also have pylab.
You have to install it in this specific directory.
No, so there's something called the default installation, right? There is also the possibility of creating sandboxes with Python. All right, so virtual environments, as they call them. And once you create a virtual environment, all the subsequent installations will happen inside that virtual environment, which actually is a subfolder, right? So you create a virtual environment which starts as a subfolder. You go into that subfolder, and then every time you do pip, all the installations are there. You can also install different versions of Python in different virtual environments, so that you're always. For you, it's probably not very interesting, though. All right, so let's go back here and let's see if we can do this now. Yay! And import pylab. So wonderful. Okay, so going back to the code, right? This list is the R that we have created. So I'm just going to say lst equals R to make things simpler to copy, right? And let's just run this 3 commands. Oh well, I think because you won't see anything until we show. We say p.show. Therefore, it's better if we just. It would have been nice if we would see one piece of plot at a time, but nevertheless, and we can say R here, and then you get one graph, right? Which is exactly the graph where we plot the points and we join the points, that right, subsequent consecutive points, we just join them by a segment, right? It doesn't look particularly nice, but if you remember at a point when we were here, right, I think here, this is the same graph, right? Just that this is done in JavaScript with a little bit more bells and whistles. Essentially what you have here is the same. I think this one can it be enlarged? Let's try to enlarge it. Okay, so that makes it a little bit better. And you can format it a little bit more. So you can decide margins. What's the amount of white space? I'm not sure what that is. Left, you can push it further to the left. All right, we can push it further to the bottom, I think. And this function, so pplot will just draw the plot, all right, and we'll set some formatting options. This KO minus, minus is, from what I remember, is drawing lines. O is the type of the point. I'm not quite sure. K is the color, which is, I think, black. And once we've set this, we can add the points, right? And we add the points as two ranges, right? The range of the x's and the range of the y's. Now, you have to remember the fact that I think, yeah, the 12 here will tell us how many dots to put on the x-axis, right? So every 12 dots, every 12 points, we should put a marker, right? And we see the years, and because of that, the years are very dense, right? So let's go here and let's say I'm going to put 120. I think we're just going to do this for the time being. And if I do this, you can see that the years are coming one by 1. We also are not seeing all the years because I think is this just right and left? If I say divided by 120 here, does that help? Oh, I see. So what I have to do here now is get rid of this one. No, we also don't see all the years. All right, so in principle, what we want to do is go to PyLab and ask graph format, pyplot tutorial. Right, so R O, for instance, R will be red, O will be a circle. So for instance, if I'm going to say G caret, I'm going to get green triangles. So that's one thing we can try very quickly. And don't worry, we're gonna get to the point. And let's not draw lines anymore. So G caret. All right, so now they're very scattered and we don't know which is which. So let's try to fix the range because we have data until, so let's look again at R. We have data until 2018, right? So so the question is, what's wrong here? Is it oh, 1982 plus land list plus 10 here. That will fix it. Oh, sorry. How do I insert the new line? And insert the new line. So here we're going to say 10. No. Okay, so that will not have an effect. Plus
Maybe we shouldn't be dividing.
oh no, so it's a range. I should say comma 10. Should say what the step is. So the step by default is 1. We should go and find out what x6 is doing. So the step here is 120, which is correct. We want one every 10 years, maybe not necessarily 10 years, but. So then here we start at 1982. Oh, yeah, 1982, and the step should be
What is the length?
no, wrong.
What is the length?
I want 12 here. Where?
The length of the list.
The length of the list is the length of the list, right? So the number of months, right? So the entire x-axis should have length of the list points, right? The OX, the horizontal axis, should have that many points, right? The problem is, where do we want, there's two things, right? Where do we want a little marker, and where do we want a number under a marker, right? So this one says, where do we want a marker? And we want a marker every year, right? But we would like a marker every year, but like a number every 10th marker, right?
It should be divided by 12.
So maybe I should go and read the, let's, so this is x6. Do we have x6 here? No. Okay, figure it out. So ticks and labels. So ticks are, the first one is the ticks. A list of explicit labels to place at given locations. Oh, I see. So what I should be doing is essentially make all of them blank except for every 10th. So we go back to 1 here. Oh. This becomes complicated, which is actually nice because we get to do some programming, right? So if I do this, going back to the original stuff, just making sure that this one goes to 2018. Cool. So what we want now right, we want the map here. So I want to map on this range. We want to map the lambda year if, and I'm going to say year if year %10 equals 0. Else the empty string. Right on this range, and we have to close an extra bracket. Yes. Okay. So another thing that we can do is use different kind of lines. I'm not sure if it can interpolate and show you a well, can show histograms. You can read about it. So the last homework is about that, right? So you're going to have to download your own data set, and you're going to be asked to do some little processing and draw a simple graph, right? So pay attention. There's some data processing. It's not like in this case we have plotted the data set directly, right? But if I remember correctly, I'm hoping. All right, so the assignment is here. Let's verify, does this still exist? What happened? Did it download it or not? Oh yeah, okay. So it downloaded it straight, right? So it has to do with rainfall. Actually, I think there's more than one data set that you have to download, right? So so it's data processing. You have to find out the year with most downfall. Then mobile usage, highest increase in mobile data. Data usage local maxima. Right, population. Oh, I think there's no drawing. All you have to do is just process. Okay, so you have the model of loading the data from the disk, right? Which is which is here, right, the get data. And instead of using plot data, you will have to have a function that just performs this processing and returns a result. And the result typically is just, I think, a single number. So let's make sure that's true. So here, yeah, so it's one of the years. Here is the highest increase, so again, one number. Data usage local maximum. So the maximum, the local, it's a local maximum, so I think it's still one number. Yes. All right, average population increase. So here, be careful that you're going to have ethnicity and age groups, so we're going to have to put the groups together, right, for the same time period. And then at some point, the current female, at least last year that was the case, the female population was larger than the male population by marginally, right? But you need to find out when that happened, in which year was that, right? So you have some historical data from the 80s, I think, and then at some point you have to find the year when, right? So previous year, male population was higher, and the year that you have to report is the first time female population was higher. It might have changed in the past year, but that's the case. Still find the first occurrence. Cool? Any questions?
So when you want to install the package?
You will, no, you won't have to install the package because you're not being asked to draw any graphs here. You're just asked to process data, right? There's no graphable data that you need to obtain.
Oh, so you don't need those?
You don't need the graphs, right? So that's just for your own, right? The fact that it's possible data scientists use these packages, and even more sophisticated packages, right? So these are packages that are drawing drafts out of data sets. You don't have to go and build the graph yourself, essentially. You're just saying, oh, these are the points, and there are some parameters. Draw it with dots, draw it with triangles, draw it with continuous lines, draw it with dotted lines. Yeah, so somewhere here there should be dotted lines.
But in general, like, what is the data type that you get from importing CSV?
You get an array, an iterator of arrays, right? Yeah. So each element in the iterator is an array representing the values in the columns, right? So each array represents one row, right? So value 0, right? Array 0 is the value in the first column of that table row. Value, or array 1, is the second column of that row, right? And so on and so forth.
So, and then array 3 would be the second row?
No. So second row will be a different array.
Oh.
You do next of iterator and you get the next element, right? Though in general you don't want to do next, you just want to use a sequence comprehension, right? A list comprehension or a set comprehension, or so whatnot.
It gets split into rows.
Yeah.
And then within each array is the column.
Yeah, within each row, so each row is represented by an array, and the array elements are values inside the columns for that row.
Is there a way to just quickly look at it as a table or something?
But you can always load it in Excel, right? So there's no point in Python giving that to you if it's so easy to load it in Excel, or you load it in a text editor, right? I mean, it's less nice, but still very, very readable, right? As separate columns. So Right now, if you go in Excel, you can already print everything or plot everything. All the plots that we would be doing in Python, there are very easy ways to do that in Excel. Just that what data scientists are doing is processing that is not very readily available in Excel, right? Excel also is not very efficient. So once you, if you have like 400 rows, there's nothing, right? But often you would have, a few million rows, which in today's computer it just fits. It's nothing. But Excel, for instance, has a limit of 2 million rows, right? If you have a data set that has 10 million rows, then Excel doesn't do anything for you, right? Now, all this matplotlib is actually a library that is imported from R. So those who know R, right, they will find it very easy to use matplotlib. Python has what we call more Pythonic libraries for processing data, right? Just that last year, a lot of the class had an R class before, right? So again, it was a good thing to show them something that they were very familiar with. Because all those, that string with K and O and minus, right? That's not very readable for a human, right? But again, so R is a very old language, and these strings have been put there because they were very concise and they didn't occupy a lot of memory, right? And then 30 years later, they still are there, even though there's no good reason to keep them that way, right?
Yeah. So like, I use R too, and it looks like it's a little more complicated to like plot something, because in R usually you have CSV, you import it, becomes something like they call it a data frame.
Yeah, data frame.
Yeah, and all you have to do is plot that, and then it comes out.
But still, so you would have to say, you would have to say what goes to the, the horizontal, the OX, the OY, right?
Yeah, but there's like a default sort of thing. X, Y.
I think there will be a default here as well. It's just that the default, I don't think it, right, because everything is a string, and we sort of wanted to convert. Did we convert? Because that was another thing that happened, kind of happened surreptitiously.
Oh, we did float.
Yes, right. So we had to float it. So yeah, I think if we had floated separately, one thing we could have done is we could have gone through the entire data set and turned everything into numbers first, instead of doing it on the fly. And then I think plot would have had some defaults, that would take care of. The notion of data frame exists as well in Python, so you can have the equivalent of a data frame.
I think it's a little hard to picture the iterations of arrays.
Yeah, but the thing is that, so from where I come from, which is functional programming, processing sequences with a map, or with these aggregation functions, that's the standard for me, right? So I also found R a little bit unwieldy, because doing this functional style programming is a bit unprincipled. It's not that it's not possible, it's a bit unprincipled. Anyway, yeah, let's figure out something. So it turns out that having had the advantage of putting 2 video lectures out, it turns out I finished a bit early. So let me figure out something to do next time. I'll try to figure out something fun. Maybe try a game. Let's see if I can find a game that I can at least come with something prepared and finish some stuff in 2 hours. There are these frameworks that are doing Python inside the browser. So they are on the fly converting it to JavaScript, and you can do animation in Python in the browser. And a while ago, I coded an asteroids game. So which I finished, maybe not in 2 hours, but not more than half a day. I mean, doing it myself and doing it in front of people does different things. So maybe I can try to dig that out and just leave inside some bits and pieces so that it's not a very full-fledged game, and then just add some features. But it will be interesting to experience for you there's different ways of using Python. I think. Yeah. My guess is that you're not going to be. Are you studying